The screen opens in darkness, and for a brief moment, there is only the sound of water. Slow, rhythmic, almost calm. Then, a satellite image fades in. Coastlines glow faintly against the deep blue of the oceans, familiar shapes we recognize instantly. But something is different. The lines are shifting. Almost imperceptibly, the edges of continents begin to blur, as if the sea itself is quietly rewriting the map of the world. This is not a distant future. This is not a theoretical scenario. This is happening now. Over the past decade, coastlines across the planet have changed faster than most people realize. Entire stretches of land have retreated. Villages that once stood safely inland now face the tide at their doorsteps. And in some places, the ocean no longer knocks. It enters, uninvited, again and again. This documentary is not about speculation. It is built on data, on satellite observations, scientific reports, and real-world events that have already taken place. Piece by piece, we reconstruct a global picture of risk, not in centuries, but within the next 10 years. The question is not whether the seas are rising. The question is, where will the impact be felt first? To understand this, we must begin far from the continents, scattered across the vast expanse of the Pacific and Indian Oceans. Here, barely rising above the surface of the water, lie nations like the Maldives and Tuvalu. From above, they look almost fragile, thin ribbons of sand and coral, surrounded by endless blue. In these places, the average elevation is measured not in meters, but in centimeters. A storm surge of just 1 meter can temporarily cover large portions of land. And such events are no longer rare. What used to be described as once-in-a-century floods are now happening every few years. But the danger here is not only the dramatic image of waves crashing over islands. It is quieter, slower, and far more relentless. Salt water seeps into freshwater reserves, contaminating wells that entire communities depend on. Soil becomes less fertile. Crops begin to fail. Even when the land is still visible, its ability to sustain life is already fading. From these low-lying islands, we move to one of the most densely populated regions on Earth, Bangladesh. A country shaped by rivers, where land and water have always coexisted in a delicate balance. But today, that balance is shifting. Satellite imagery reveals a complex network of rivers feeding into the Bay of Bengal. During the monsoon season, these rivers swell dramatically. Now add rising sea levels to this equation, and the result is a compounding effect. Water no longer drains as efficiently. Floodwaters linger longer. And when powerful cyclones push storm surges inland, they travel further than ever before. In some regions, millions of people live just a few meters above sea level. Infrastructure, roads, schools, hospitals, is increasingly exposed. Each major storm does not just cause temporary disruption, it erodes resilience. Recovery becomes slower. The margin for safety becomes thinner. Now we turn to Southeast Asia, to the Mekong Delta in Vietnam, a region often described as one of the most productive agricultural zones in the world. Seen from above, it is a vast green patchwork of rice fields, canals, and towns, all interwoven with water. But beneath this fertile landscape lies a growing vulnerability. The delta is not only affected by rising seas, but also by land subsidence. Groundwater extraction and sediment reduction mean that the land itself is slowly sinking. This creates a double impact. As the ocean rises, the ground falls. Saltwater intrusion is now reaching deeper inland than ever recorded. Fields that once produced abundant harvests are becoming less reliable. Urban areas face increasing tidal flooding, not during storms, but during regular high tides. Streets fill with water not because of extreme weather, but because the baseline has shifted. Further west, along the Mediterranean coast, lies the Nile Delta in Egypt. For thousands of years, this region has been sustained by the annual rhythms of the Nile. It is one of the oldest continuously inhabited agricultural areas in human history. Yet today, the delta faces a convergence of risks. Rising sea levels press from the north, while reduced sediment flow from upstream limits the natural rebuilding of land. At the same time, parts of the delta are subsiding, sinking gradually over time. Coastal erosion is visibly reshaping the shoreline. Protective sand barriers weaken. Saltwater moves into groundwater systems. And as in other vulnerable regions, the changes are not always sudden, but they are cumulative. Each year adds a small increment. Each decade reveals a larger transformation. But not all nations respond to this challenge in the same way. To understand what is possible, we look to the Netherlands, a country that has lived with water for centuries. Here, large portions of land already lie below sea level. Yet instead of retreating, the Netherlands has built an intricate system of defenses. Dikes, storm surge barriers, and advanced pumping systems work together to manage water with precision. Massive engineering projects, such as movable barriers that can close during extreme storms, demonstrate a different approach. Not avoidance, but control. Continuous monitoring, constant upgrades, and long-term planning allow the country to adapt as conditions change. However, even in the Netherlands, the challenge is ongoing. Systems that were once sufficient must now be reinforced. Designs must account for higher projections. The margin for error is carefully managed, but never ignored. Across all these regions, one pattern becomes clear. Rising sea levels are not a single, uniform threat. They interact with local conditions, topography, population density, infrastructure, and natural defenses. The same increase in water level can have vastly different consequences depending on where it occurs. To fully understand what is happening, we need to look at the mechanisms behind the rising seas. Two primary processes are driving this change. The first is the melting of ice, glaciers and ice sheets releasing vast amounts of water into the oceans. The second is thermal expansion. As ocean water warms, it expands, increasing in volume even without additional input. These processes are gradual, but their effects are amplified during extreme events. Storm surges, for example, occur when strong winds push seawater toward the coast. When combined with higher baseline sea levels, these surges reach further inland, affecting areas that were previously considered safe. At the same time, another factor is often overlooked: land subsidence. In many coastal regions, the ground is sinking due to natural processes or human activity. This effectively accelerates relative sea level rise, making the situation more severe than global averages might suggest. And then, there are the tides. In some cities, what used to be rare nuisance flooding during high tides is becoming a regular occurrence. Streets flood not during storms, but on clear days. This repetition has a cumulative effect, weakening infrastructure, disrupting daily life, and signaling a deeper shift. What makes this situation particularly complex is the contrast between slow and sudden change. On one hand, sea levels rise gradually, almost invisibly. On the other, a single night of extreme flooding can transform an entire region. Ports, airports, and urban centers can be temporarily paralyzed within hours. The maps used by scientists to track these risks are constantly evolving. New data leads to updated projections. Areas once considered safe are reclassified. And as these maps change, so do the decisions that governments and communities must make. Some cities invest heavily in protective infrastructure, seawalls, drainage systems, and pumps. Others focus on adaptation strategies, such as elevating buildings or restoring natural barriers like mangroves and coral reefs. In some cases, relocation becomes part of the discussion. At the core of all these efforts is a simple reality: water follows its own logic. It moves according to physics, not politics. It does not negotiate. It responds to temperature, gravity, and terrain. And as we continue to observe the shifting coastlines of our planet, one question becomes increasingly urgent: not just which countries are at risk, but how quickly the line between land and sea is being redrawn. The answer is already visible if we know where to look. The story does not end with rising water alone. To understand which countries are most at risk, scientists look for patterns, signals hidden in geography, climate, and human activity. These signals form a kind of checklist, a way to measure how vulnerable a place truly is, not in theory, but in reality. One of the most critical factors is elevation. Not the highest mountains or hills, but the average height of land where people actually live. In many coastal regions, entire cities and agricultural zones sit just 1 or 2 meters above sea level. On a map, this difference seems insignificant. In reality, it is the line between safety and repeated flooding. Another key factor is storm frequency and intensity. Regions that experience powerful cyclones, hurricanes, or typhoons face a compounding risk. Rising seas lift the baseline, and storms build on top of that. What was once a manageable surge becomes a destructive force, capable of reaching further inland with each passing year. Erosion is another silent indicator. Coastlines are not fixed. They are constantly shaped by waves, currents, and sediment movement. But when erosion accelerates, it becomes a warning sign. Beaches narrow, natural barriers disappear, and with them, the first line of defense against the ocean is lost. Mangrove forests and coral reefs play a crucial role in this system. They act as natural buffers, absorbing wave energy and reducing the impact of storm surges. But in many parts of the world, these ecosystems are under pressure from pollution, development, and rising temperatures. As they degrade, the protection they offer weakens. Urbanization adds another layer of complexity. As cities expand toward the coastline, they bring infrastructure, population, and economic activity into increasingly vulnerable zones. Roads, ports, power systems all become exposed, and once built, these systems are difficult and costly to move. When scientists combine these factors, elevation, storm patterns, erosion, natural defenses, and urban growth, they begin to see a clearer picture. Not just where water might go, but where the consequences will be most severe. But risk is not only about geography, it is also about time. Sea level rise is often described as a slow process, measured in millimeters per year. But this gradual increase sets the stage for sudden events. A storm that might have caused minor flooding decades ago can now trigger widespread disruption. The difference is not always visible in advance, but it becomes undeniable in the moment it happens. Imagine a coastal city at night. The streets are quiet. The tide begins to rise, as it always does. But this time, it does not stop at the usual boundary. Water spills over into roads, into homes, into critical infrastructure. By morning, the city is partially submerged, not by a catastrophic wave, but by a combination of small changes that have accumulated over time. This is the nature of modern flooding. It is both predictable and surprising. Scientists can model probabilities, estimate scenarios, and map risk zones. But the exact timing, the precise impact of a single event, remains difficult to predict. This is why risk maps are constantly being updated. Advances in satellite technology and data analysis allow for more precise measurements. Elevation models become more accurate. Flood simulations incorporate more variables. And with each update, the understanding of vulnerability evolves. In some cases, areas previously considered safe are reclassified as high risk. In others, new protective measures reduce exposure. The map is not static. It is a living document, reflecting both environmental change and human response. And that response varies widely from one place to another. In regions with strong economic resources, large-scale engineering projects are often the first line of defense. Seawalls rise along coastlines. Storm surge barriers are constructed at the mouths of rivers. Pumping systems are installed to remove excess water during high tides and heavy rainfall. These systems can be highly effective, but they require constant maintenance and adaptation. As conditions change, so must the infrastructure. What works today may not be sufficient tomorrow. In other regions, the focus shifts toward adaptation rather than resistance. Buildings are elevated. Flood-resilient designs are implemented. Communities develop early warning systems to prepare for incoming storms. Evacuation plans become more structured, more practiced. Nature-based solutions are also gaining attention. Restoring mangroves, protecting wetlands, and rebuilding coral reefs can provide a buffer that works with natural processes rather than against them. These approaches are often more sustainable, but they take time to develop and require careful management. In some cases, the most difficult decision emerges: relocation. Moving communities away from high-risk areas is not simply a technical challenge. It is social, cultural, and economic. Homes, histories, and identities are tied to the land. Leaving is not just a physical shift. It is a profound transformation. Yet in certain places, this conversation has already begun. What becomes clear is that there is no single solution. Each region faces a unique combination of risks and constraints. What works in one country may not be applicable in another. The strategies differ, but the underlying challenge is shared. And as we look across the globe, a pattern begins to emerge. The countries most at risk are not always the ones contributing most to the problem. Many of the most vulnerable regions are those with limited resources to respond, limited infrastructure to adapt, and limited time to prepare. This imbalance adds another layer to the story, not just environmental, but geopolitical. Because as coastlines change, so do boundaries, not just physical ones, but economic and social boundaries as well. Migration patterns may shift, resource distribution may change, entire nations could be redefined by the movement of water. But beyond the global scale, the reality remains deeply local. A fisherman in a delta notices that the tides reach further each year. A farmer sees salt water creeping into the soil. A family experiences flooding not once, but repeatedly until it becomes part of life. These are not abstract data points. They are lived experiences repeated across different regions, connected by a common cause. And still, the process continues, quietly, steadily. The ocean does not rush all at once. It advances in increments, a few centimeters, a few meters during a storm, a coastline reshaped over years. And then suddenly, a threshold is crossed. A road becomes unusable. A neighborhood becomes uninhabitable. A system designed for past conditions begins to fail. These thresholds are not always visible in advance, but once crossed, they are difficult to reverse. So the question is no longer whether change is happening, it is how societies respond to it, how they interpret the signals, how they act on the data, and how they prepare for what comes next. Because the maps already show where the water is close. They reveal the low-lying lands, the exposed cities, the fragile coastlines. They highlight the places where the balance is most delicate. And in those places, the future is not a distant concept. It is already beginning to take shape. The line between land and sea has never been fixed. But now, it is moving faster than before. And as it moves, it forces a decision, not between stopping nature, but between understanding it or being overtaken by it.